Hello everyone, today we're going to solve this third degree equation. X cubed plus x squared equals to 12. The first thing I'm going to do is to move this 12 to the left side, changing the sign. So we will have the following equation here. As we have an exponent 3 here, that is x cubed, and the exponent 2, which is x squared, I can rewrite this minus 12 like minus 8 and minus 4. This here is still minus 12. So we will have x cubed plus x squared minus this 8. I can rewrite it as 2 cubed minus this 4. I'll rewrite it as 2 squared, and this is equal to 0. So now I have here x cubed minus 2 cubed, and I have here x squared minus 2 squared, and now I'm going to rewrite it like x cubed minus 2 cubed plus x squared minus 2 squared, and all of these are equal to 0. Notice that here we can apply a rule: a cubed minus b cubed is equal to a minus b times, open the brackets, the a squared plus a times b plus b squared. And don't confuse this term with the square of the sum of two terms. There is no 2 in the middle here, okay? Next, this here is also a very well-known rule. A squared minus b squared is a plus b times a minus b, or a minus b times a plus b. There is no difference, it's same. Now we will have the following. The first term is x, and the second term is 2, so it will be x minus 2 times the first term squared plus the product, which is 2x, plus the second term squared, which is 4. And this here is going to be first term plus the second term times the first term minus the second term. All of these have to be equal to 0. Okay, good. What's next? We have this factor x minus 2, which is common to both terms. So what I'm going to do is to eliminate this factor from each term by eliminating from here. So we will have this x squared plus 2x plus 4, and also this term here is going to be left with x plus 2 equal to 0. Let's solve it further. 2x plus x is 3x, 4 plus 2 is 6, and being equal to 0, this product will be equal to 0 if at least one of these two factors is equal to 0. So you can think of this product will be equal to 0 if x minus 2 is equal to 0, or if x squared plus 3x plus 6 is equal to 0. We now have two equations. This one is a very simple first degree equation. Isolating x in this equation will leave x equal to 2. So this here is the first root of our third degree equation. Now I'm going to find the roots of this quadratic equation. So I find the other two roots of our initial equation, remembering that if the equation is of the third degree, that means I have 3 roots, okay? So now, solving this quadratic equation, the first step is to separate the coefficients. So the coefficient a is 1, and the coefficient b is 3, and the coefficient c is equal to 6. I'm going to find the discriminant, which is given by this expression, b squared minus 4 times a times c. Substituting the coefficients, 3 squared minus 4 times 1 times 6, so it's 9 minus 4 times 1 times 6, which is 24. So 9 minus 24, I have minus 15. See, I have a negative discriminant. So we'll have the following. Minus 3 plus or minus the square root of minus 15 over 2, and the roots here will be complex, belonging to the set of complex numbers. Now I want to explain to you something important related to the set of complex numbers. You need to remember that the square root of minus 1, we call it I, so we're going to use this concept here. But first we need to work on this square root of minus 15. Here it's still minus 15, So I have this multiplication inside the root. I separate it into two roots, so it's square root of 15 times the square root of minus 1. But we have just seen that by definition, the square root of minus 1 is equal to I. So I can write it like this. The square root of 15 times I. And that's minus 3 plus or minus the square root of 15 times I over 2. So from here we can have two possible values. But first, let me go back here as we have already found x being equal to 2. This one I'm going to call it the first root. So x1 is equal to 2. Okay? So this is the first root of our equation. The second root, x2, will be equal to minus 3 plus the square root of 15 times I over 2. So this is the second root. Next, x3, the third root, will be minus 3 minus the square root of 15 times I over 2. So here are the three roots of our third degree equation. That's it. Thanks for watching and please subscribe to the channel. If you didn't understand some parts, just write in the comments below. I'll try to answer.